Welcome to No Electric Tech, your one stop solution for all technical clarification on electrical switchgears. Today we are going to see what is a fuse, parts of a fuse, and working principle of a fuse. What is a short circuit fault? Short circuit is nothing but a conductive path between two conductors. The severity of a short circuit fault is very high. So it is one of the most deadliest fault in any electrical system. To calculate the short circuit level in a system, you can use this formula. The short circuit current is equal to PT, that is rated power of the transformer, divided by U2E, rated secondary voltage, into root 3 into 1 divided by short circuit voltage. If you use this formula, you can find out the short circuit current of a transformer. And next, benefits of using a fuse. Point number 1, it has a very high short circuit withstand capacity, even up to 100 and 150 kA, which leads to better safety. Minimum let through energy, that is, the fault is cleared very fastly, so that the minimum fault current or fault energy goes downstream. Perfectly graded selectivity for optimal cable size and contactor rating. Simple selectivity for cascade connection of fuses. Usually between the upstream and downstream, the difference will be 1.6. That is, if the downstream is 100 amps, the upstream should be selected as 160 ampere. This is just a thumb rule. Low power loss leads to low running cost and minimum heating. And this is how a fuse looks like. We'll see the various parts of the fuse. Point number 1, melting element. This is a melting element. Number 2, these are the restrictions. Number 3, this is a solder. And this is a quartz sand. Inside the fuse bottle, this is a fuse bottle. Quartz sand is filled up. And number 5 is the indication wire. This is the indication wire, which is connected on the top to an indicator. And the number 7 is the isolated body, which is made up of usually porcelain. And this is the contact blade, and this is the gripping lug. So these are the parts. This is the fuse construction, and parts of the fuse we'll see about each part. The insulation body. The insulation body, it prevents the ejection of hot gases and liquid metal into the environment. The cover plates are provided with gripping lugs to withstand any amount of fault. The sand is also very important in achieving the current limitation, because when the fuse blows out or when the fuse element melts, the melted components are settled down or absorbed by the sand, and that heat is dissipated to the outside atmosphere. And next, moving on, the fuse element, which is very critical. On reaching the overload or short circuit level, the fuse element takes the time according to the respective time current characteristics of the fuse, and it melts. The indicating device, which is nothing but a small pop-up indicator on the top of the fuse, which will be red in color, which pops out if the fuse is open. The solder causes the time current characteristics to be shifted to the lower melting currents. The blade contacts are designed to electrically and mechanically connect the fuse link with the fuse base, which can be a switch or a fuse base as well. They are usually made of copper or copper alloy and silver plated for better conductivity. And this is how a fuse looks like, a normal rated fuse. And here the fuse, it will be, this area will be enclosed inside a fuse porcelain casing, and these are the internal elements in the fuse connected by small links. For the normal current rating of 63 ampere, the normal current flows from top to bottom. If the current exceeds the normal level of 63 ampere, we call it as overload. On overload, here it is double the current rating of the fuse. A partial melting happens in the middle, in the elements. For a short circuit fault of 5 kiloampere, almost all the links and joints are melted. And for a severe fault short circuit current, the complete thing is melted and the fuse blows out, and it saves the downstream switch gears and cables. And this is the time current characteristics. Time current characteristics is nothing but for a small value of fault current, we can take this point. For 200 amperes, 300 amperes, it takes about 3 seconds time. You can see from this graph like this. But if you take for 500 amps current, it takes about 0.15 milliseconds. So what you can observe from this graph is that for higher current rating, the fuse takes smaller time, and for smaller current, it takes a little bit higher time according to the graph. I hope that you are confident about this fuse as a switchgear product, which is a very very basic switchgear product, and we will continue in the many sessions to come. Thank you and see you once again. Bye bye.